Okay, the first question says true or false. Linear approximation says that the vertical change in the graph is approximately equal to the vertical change in a tangent line. The answer is true. That is essentially what we're doing. We're using the tangent line to predict what the next y value would be. So let's look at number 2. We'll explain more of the answer to. I'm not using my words. We'll explain this why that is true by doing this right here. So I'm going to use an illustration to help us understand this question. This says estimate. Okay, that's the nature of our section right here. We're doing a lot of estimating. Estimate this if you know this. Okay, so what is that actually asking us? Now this you guys should know is the change in g. Now if you remember, the change in g is the change in your y values. Yeah? So I'm going to make up a graph. I'm going to make up a g. We don't know what g looks like, right? Let's just say that he looks like this. I don't know. And so the first value that they give us is 1. That's going to be 1 right there. And it wants to know 1.2. So we're going to say this is 1.2 right here. This is always going to be like your A. Like in the formulas, that's your A. This right here is the A plus the change in the X. And remember, you want the change in your X to be small, because whenever you're doing approximating, the smaller that the change is, the more accurate your prediction is going to be. So we don't really know what the g is. I don't know if it looks like this. It's just a visual. But we do know where. Actually, we don't know exactly where this is, where this point is. But we do know what g prime of 1 is. But let's pretend we did know where that point was. What we don't know is where 1.2 is. And so what we're going to do is we're going to try to make a prediction. Like, where is the next point going to be? And the way you do that, the way you make a prediction is you make a tangent line right where the point is that you know, and then you make a prediction on where the next point's going to be. Now, if I have a really small change, then the prediction is going to be really close to our previous point. But if I have a bigger change, it's going to be different. It's going to be more far off. Now let's kind of play with the idea here. If that's where our point is, that can be a really good guess or it can be a really bad estimation based on what the function actually does do. Like, what if it went down like that? Or what if it went up, actually? What if it leveled off and then started going down? I don't know. But the point is that this is just an estimation, right? So, how do we figure out, or how do we estimate the change in g? The change in g is going to be this, which is this point right here, minus this right here, this point right here. So this would be, let's say this is g of 1, and this next one is going to be g of 1.2. So what is this change? Like, what is the difference, or what's the distance between those two? That's what we're estimating here. That's, I think they use the word linear approximation a lot just for that, for the change in g. So how do we figure that out? This is where we use this guy. The change in g is approximately equal to the g prime of a times the change in x. Now, what does g prime of a represent? That represents the slope. At this point right there, at the first point, g prime of a represents the slope. Do we know what g prime of a is right now? Right there. It tells us. So I can plug in 4 right there. Now we have the change in x. What is the change in x? 0.2, right? 0.2. So this is going to approximate the change to our next point. And so we multiply those two together, you get 0.8. Approximately 0.8. So this is approximately 0.8. The change in g is approximately that. So that's the linear approximation part. Now let's look at, and what do we use? We use the tangent line, right? The tangent line tells us approximately where the next point's going to be. Now this one just asks for the change. This one down here, what is this one asking? Now you got to read it carefully and slow. What is it actually asking? Let's see. It says estimate f of 2.1 if, and so then it gives us stuff to try to do it. And so we actually can stop right there, and we can know what this is asking. What does that want? It wants a y value. Like, what is the y value? Now, if we took this question up to this question, up here it would be saying, okay, what is the value, the y value of that point that we're guessing? That's what this question is asking. It's asking, what is that new point? So, we're going to do the same thing. Do you guys like the visual? Does the visual help? Okay, well, some it helps, some it doesn't. Because we don't know what f is, I'm going to draw a random line, a random curve, just so we have a visual. We'll say that this is, I don't know, we'll say, oh, it's